Hey everyone, welcome to EasyMath, and in this video, we are going to learn how to evaluate limits of function. Okay, so let's start with this example. We have limits of 2x minus 7 as x approaches to 4. In order for us to solve this limits of function, we're just going to use this substitution. Okay, so we are just going to substitute the value of x into this function. Okay, so let's answer this problem. So we have 2 multiplied by the value of x, which is 4, minus 7. Okay, so 2 multiplied by 4 is just equal to 8 minus 7. Okay, so we have 8 minus 7 is just equal to 1. Okay, so the answer of the limits of 2x minus 7 as x approaches to 4 is equal to 1. Okay, so let's have another example. We have limits of x squared minus 5x plus 6 as x approaches to 3. Okay, so we are just going to substitute the value of x into this function. Okay, so again, we have to substitute the value of x. So the value of x is equal to 3. Okay, so squared minus 5 multiplied by the value of x, which is 3, plus 6. Okay, so 3 squared is just equal to 9. Negative 5 multiplied by 3 is just equal to negative 15. Then plus 6 is just equal to 0. Okay, so the answer of limits of x squared minus 5x plus 6 as x approaches to 3 is just equal to 0. Okay, so let's have another example. We have limits of 4x cubed minus 3x squared plus 2x minus 5 as x approaches to 1. Okay, again, we're just going to substitute the value of x into this function. Okay, so we have 4 times the value of x cubed minus 3 times the value of x squared plus 2 times the value of x is 1 minus 5. Okay, so we are just going to simplify. So 4 times 1 cube just equal to 4. Then we have negative 3 times 1 squared is just equal to 3, negative 3. And positive 2 times positive 1 is just positive 2 minus 5. Okay, so simplify, we have 4 minus 3 plus 2 minus 5. We have negative 2. Okay, so the answer of limits of 4x cubed minus 3x squared plus 2x minus 5 as x approaches to 1 is just equal to negative 1. Okay, so this is the correct answer. Okay, so now, how about if we are given a rational expression? Okay, So let's try to solve this problem. We have limits of negative x squared minus 1 all over x minus 1 as x approaches to 1. Okay, so let's try to use the substitution strategy. No? So all we need to do is just to substitute the value of x into this function. Okay, let's try. Negative. So the value of x is just equal to 1. So we have 1 squared minus 1, and we have 1 minus 1. Okay, so we're just going to simplify. So we have 1 minus 1 all over 1 minus. So we have negative 0 all over 0. So this is in indeterminate form. To solve this problem, we are just going to factorize this expression. Okay, so let's erase this solution. So first, we're just going to factorize this expression. So we have x squared minus 1 can be written in this form: the quantity of x plus 1 multiplied by x minus 1 all over x minus 1. So let's rewrite the limit expression. So as you can see, we can cancel out x minus 1. Okay, so the remaining expression is negative x plus 1. So let's rewrite the limit expression. Now let's simplify the expression. We can distribute the scalar value, which is negative 1, into the inner terms. So we have negative 1 multiplied by x. We have negative x. Then negative 1 multiplied by positive 1. We have negative 1. Okay, so let's uh, copy the limit expression. Now we can try to use the substitution strategy. No? So we have negative x. So the value of x is equal to 1. So we have to substitute minus 1. And the final answer is negative 2. So the answer of limit of negative x squared minus 1 all over x minus 1 as x approaches to 1 just equal to negative 2. Okay, okay, so let's have another example. Limits negative x squared minus 5x all over x minus 5 as x approaches to 5. So let us try to use the substitution strategy. So the value of x is just equal to 5. So we're just going to substitute the value of x. Uh, 5 squared minus 5 multiplied by 5. Then 5 minus 5, we have negative 25 plus 25, and 5 minus 5, and we have negative 0 all over 0. Again, this is indeterminate form. And to solve this problem, we're just going to factorize this expression. Okay, so let's try to factorize the expression. Okay, so we have this, so we can factor out x. So x is the common factor. So we'll divide this terms by x. So x squared divide x just equal to x. So negative 5x divide x just negative 5 all over x minus 5. So we can cancel x minus 5 and copy the expression. So as you can see, we have negative x left. Now we can try to use the substitution strategy. So the value of x is just 5. So we're just going to substitute the value of x is 5. So we have final answer is negative 5. So the answer of limits of negative x squared minus 5x all over x minus 5 as x approaches to 5 is equal to negative 5. Okay, so let's have another example. Limits of negative x squared minus x minus 2 all over x minus 2 as x approaches to 2. Okay, so let's try to use the substitution strategy. So the value of x is equal to 2. So we're just going to substitute the value of x. So we have 2 squared minus 2 plus 2. We have 2 minus 2. Okay, so we're just going to simplify. We have 4 minus 2 minus 2 all over 2 minus 2. Okay, so we have 4 minus negative 2 minus 2 is just negative 4. Then 2 minus 2. So we have negative 0 all over 0. So as you can see, it's still in indeterminate form. So we can solve this problem by factoring this expression. Okay, so let's erase this solution. So we can rewrite the numerator as the quantity of x minus 2 multiplied by x plus 1. Okay, so copy the denominator of x minus. As you can see, we can cancel x minus 2 out. This, then copy the limit expression. Okay, so we have negative x plus 1 is the expression is left. So we can copy the limit expression. Limit of x as x approaches to. We can simplify. We can just distribute the scalar value negative 1 to the integers. So negative 1 multiplied by x equal to negative. Then negative 1 multiplied by positive 1 just negative 1. Okay, so let's copy the limit expression. right? So you can use the substitution property. So the value of x is just equal to 2. So you have to distribute or to substitute the variable x by 2. So the value of x is 2. So we're just going to substitute plus 1. We have negative 2 minus 1 just equal to negative 3. So the answer of limits of negative x squared minus x minus 2 all over x minus 2 as x approaches to 2 is equal to negative 3. So this is the correct answer. Okay, so let's have another example. We have limits of x squared plus 3x minus 10 all over x plus 5 as x approaches to negative 5. Okay, so let's try to use the substitution strategy. So let's just substitute the value of x into this function. So we have negative 5 squared plus 3 multiplied by negative 5 minus 10 all over negative 5 plus 5. So we have negative 5 squared is just equal to 25. Then positive 3 multiplied by negative 5 is just negative 15 minus 10 all over negative 5 plus 5. So we have 25 minus 15 is just equal to positive 10. Okay, so we have 0 over 0. So this is in indeterminate form. So we are just going to factorize this expression, okay, to solve this problem. Okay, so the numerator, you can just rewrite this into the quantity of x minus 5 times the quantity of x plus 2. Oh, wait. Uh, you have the quantity of x plus 5 multiplied by the quantity of x minus 2 all over x plus 5. Okay, so let's rewrite the limit expression. Okay, so as you can see, we can cancel x plus 5. So we have x minus 2. So we're going to rewrite the limit expression. So now we can try to use the substitution strategy. So we have the value of x is just equal to negative 5. So we're just going to substitute the value of x, which is negative 5. So we have negative 5 minus 2 is equal to negative 7. So the answer limit of x squared plus 3x minus 10 all over x plus 5 as x approaches to negative 5 is equal to negative 7. So this is the correct answer. Okay, so now we have our last example. We have limits of x over 1 over 3 plus x minus 1/3 as x approaches to -3. Okay, so now you're just going to simplify this expression. So we have x all over 1 over 3 plus x minus 1/3. So we're just going to simplify the denominator by finding the LCD. So the LCD is just 3 plus x multiplied by 3. Okay. So now we are just going to divide the LCD by each of these terms. So 3 plus x times 3 divided by 3 plus x. So we just cancel this out. Then 3 times 1 just equal to 3. Minus, should put parentheses here. So 3 plus x multiplied by 3 times or divided by 3 just equal to 3 plus x. So we just cancel the 3 out. So 3 plus x multiplied by 1 just equal to 3 plus x. Okay. So now we're just going to simplify the expression x over 3. Then we're just going to distribute this scalar value, which is -1. So we have -3 plus x all over the substitute the scalar value, which is 3. So 3 times 3 just equal to 9 plus 3x. Okay. So now we can cancel this out. So we have x over -x all over 9 plus 3x. So we're just going to get the reciprocal. So x multiplied by the reciprocal of the denominator, we have 9 plus 3x, then negative. So now we can cancel x and negative x. So the remaining expression is just negative times the quantity of 9 plus 3x. Okay, so now we're just going to substitute or distribute the scalar value, which is -1. So -1 times 9 just equal to -9. Then -1 times 3x is just equal to -3x. So just copy the limit expression, which is limit then as x approaches to -3. We have -9 minus 3x, copy the limit expression. So now we can use the substitution strategy. So the value of x is just -3. So we're just going to substitute the value of x. So -9 minus 3 times the value of x, which is -3. So we have -9, then -3 multiplied by -3 is just +9. So we have -9 plus 9 is equal to 0. So the answer is, or the correct answer is 0. And that's how you evaluate limits in calculus. If you found this helpful, don't forget to like, subscribe, and check out my next video.